Hello students, good morning. Today I am going to teach significant figures from the first chapter. What do you mean by significant? Significant means important. That is, number of meaningful digits are known as significant figures. Number of meaningful digits are known as significant figures. The digits which tell us the number of units that are sure in making a measurement are called significant figures. The digits that are known reliably plus the first uncertain digit are known as significant figure or significant digits. The digits that are known reliably plus the first uncertain digit are known as significant figures or significant digits. For example, the value of gravitational constant. The value of gravitational constant is 6.673 etc. into 10 power minus 11 Newton meter square kg raised to minus 2. Here 6 and 6 are reliable. 7 is uncertain. 6 and 6 are sure number. 7 is uncertain number. So how can we write the significant figure? The digits which are reliably plus the first uncertain digit are known as significant figure. So here 6, 6, 7. These three digits are significant figures. So the measured value has three significant figures. Now let us see the rules for counting the significant figures. There are few rules given in your book. First rule is all non-zero digits are significant. All non-zero digits are significant. Example 1346. So here there is no zeros. All the digits are non-zero. So all non-zero digits are significant. So 1, 2, 3, 4. So how many significant figures? 4 significant figures. Another one example 5, 2, 3. This number has 3 significant figures. So all non-zero digits are significant figures. Second rule. All zeros between two non-zero digits are significant. All zeros between two non-zero digits are significant. For example, 3, 0, 0, 0, 5. In this number, 3 and 5 are non-zero digit. In between 3 zeros are there. So these zeros are included for the significant figure. So how many significant figures are there? 1, 2, 3, 4, 5. So it has 5 significant figure. All the zeros between the two non-zero digits are significant. So 2008 means it has 4 significant figure. Third rule is all zeros to the right of a non-zero digit but to the left of a decimal point are significant. All zeros to the right of a non-zero digit but to the left of a decimal point are significant. So here we are considering decimal point number. For example, 30700 decimal point. How many significant figures are there? All the zeros to the right of the decimal point, all the zeros to the right of a non-zero digit but to the left of the decimal point are significant. So here this is already significant and these two zeros also significant because it is a decimal point. So 1, 2, 3, 4, 5. So this number has 5 significant figures. all zeros to the right of the non-zero digit but to the left of a decimal point are significant. Next rule. The number without a decimal point, the terminal or trailing zero are not significant. The number without a decimal point, the terminal or trailing zeros are not significant. For example, the same number when we are considering without decimal point, 30700. Here there is no decimal point. So without decimal point, the terminal zeros or trailing zeros are not significant. So this cannot be included for significant figure. So how many significant figures? 1, 2, 3. So it has 3 significant figures. The next rule. All zeros are significant if they come from a measurement. All zeros are significant if they come from a measurement. The same example when we consider, suppose the measurement is 30700 meter. It means it comes under a measurement. So these zeros also included for significant. So how many significant figure for this number? 1, 2, 3, 4, 5. So this has 5 significant figures. All zeros are significant if they come from a measurement. Here the meter shows us the measurement. So we can include these 2 zeros also. This number has 1, 2, 3, 4, 5 significant figures. The next rule. If the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digits are not significant. If the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digits are not significant. For example, 0.00345. It has how many significant figures? 3 significant figures. That is, the zeros to the right of the decimal point and to the left of the non-zero digits are not significant when the number is less than 1. So less than 1, these are not significant. So 1, 2, 3. So it has 3 significant figure. The 7th rule is all zeros to the right of a decimal point and to the right of non-zero digits are significant. All zeros to the right of a decimal point and to the right of non-zero digits are significant. This comes under the number is greater than 1. For example, the number 40.00. It has how many significant figures? 4 significant figures. How? All zeros to the right of the decimal point and to the right of the non-zero digit are significant. So this number has 4 significant figure. Here the number is considered as greater than 1. The last rule is the number of significant figures does not depend on the system of units used. The number of significant figures does not depend on the system of units used. For example, .53 centimeter can be written as 0.0153 meter. Otherwise, 0.0000 0.153 kilometer. So here centimeter, meter, kilometer. But all the three values have same number of significant figure as number 3. 1.53 centimeter has 3 significant figure. This 0.0153 less than 1. So this is not included. So it has 3 significant figure. And here 0.000153 kilometer. Here also less than 1. So these zeros are not significant. So 153. So this number also has 3 significant figures. So number of significant figures does not depend on the system of units used. Also, the power of 10 is irrelevant to the determination of significant figure. Power of 10 is the same concept. The power of 10 is irrelevant to the determination of significant figure. For example, x is equal to 5.70 meter can be written as 5.70 into 10 power 2 centimeter, or else can be written as 5.70 into 10 power 3 millimeters. So all these systems has the significant figure as 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So the power of 10 is irrelevant to the determination of significant figures. I think you understood the rules for significant figure. Let us check the examples. First number 600,800. How many significant figures are there? Yes, there are 4 significant figures. 1, 2, 3, 4. This is not included. Second, 2.65 into 10 power 24 meter. How many significant figures are there? Yes, 3. That is 1, 2, 3. The power of 10 is irrelevant. 0.007. How many significant figures are there? Yes, only one significant figure because the number is less than 1. So these zeros are not included for significant figures. Students, you have to practice the examples from the book. The next one is rounding off. Nowadays we are using calculators for doing calculations. When you do the calculations, the calculators may display so many figures. The result given by a calculation has too many figures. For example, 11.65333321 etc. So all the digits displayed from the calculator we are not using. We have to be rounding off. The result of calculation with the numbers containing more than one uncertain digit should be rounded off. After the decimal point we will use either 2 or 3 or mostly 2 digits we are using. So the uncertain digits should be rounded off. There are some rules for rounding off. Let us see the rules for rounding off. First rule. If the digit to be dropped is smaller than 5, then preceding digit should be left unchanged. The digit to be dropped is smaller than 5, less than 5. Then the preceding digit, the previous digit, should be left unchanged. For example, 7.32. This number is rounded off to 7.3. So this number to be dropped, it has less than 5. So less than 5 means the preceding digit left unchanged. As it is, we have to write. So 7.3. Similarly, 8.94. It is rounded off to 8.9. Second rule. If the digit to be dropped is greater than 5, then the preceding digit should be increased by 1. The number to be dropped is greater than 5, then the preceding digit should be increased by 1. For example, 17.26 is rounded off to 17.3. 6 is greater than 5, so the preceding digit should be increased by 1. 11.5, 11.89. So here it is rounded off to 11.9. This number is greater than 5, so preceding digit should be added by 1. The next rule is, if the digit to be dropped is 5 followed by digits other than 0, then preceding digit should be raised by 1. The digit to be dropped is 5 followed by digits other than 0. 5 followed by number. Then the preceding digit should be raised by 1. For example, 7.352. This being on rounded off to first decimal becomes 7.4. So the digit to be dropped is 5 followed by other than 0. Here 5 followed by 2. So preceding digit should be raised by 1. So it is rounded off to 7.4. Similarly, 18.159. It will be rounded off to 18.2. 5 followed by other than 0. So preceding digit should be raised by 1. The next rule is, if the digit to be dropped is 5 or 5 followed by zeros, 5 or 5 followed by zeros, then the preceding digit is not changed if it is even. If the digit to be dropped is 5 or 5 followed by zeros, then the preceding digit is not changed if it is even. For example, 3.45. It is rounded off to 3.4. So here the number to be dropped is 5. The previous digit is, that is preceding digit is even. So if it is even, it should not be increased by 1. As it is, we have to write. So how the 3.45 is rounded off? It is rounded off to 3.4. That is, the digit to be dropped is 5 followed by zeros. Then the preceding digit is not changed if it is even. Okay. 8.250. 5 followed by zeros. If it is even, it should not be changed to 1. So we can write 8.2. The next rule. If the digit to be dropped is 5 or 5 followed by zeros, then the preceding digit is raised by 1 if it is odd. If the preceding digit is odd, we can increase the number by 1. For example, 3.35 is rounded off to 3.4. 5. The digit to be dropped is 5. The preceding digit is raised by 1 because it is odd. If it is even, should not rise. If it is odd, you have to add 1. So, another example we can see 8.350 is rounded off to 8.4. It is to be dropped is 5 followed by zeros and the preceding digit is odd. So, we can round it off to 8.4. I think you understood the rules for rounding off. Try this questions. Round off the following numbers. 19.45 up to 3 digits. 19.45 up to 3 digits. How can we write? 19.4. Here it is 5. The preceding digit is even. So it should not be changed as increased by 1. So as it is we can write 19.4. Another example. 12.653 up to 3 digits. So here the answer is 12.7. 18.35 up to 3 digits. How can we round off? 18.35 means it is 18.4. So it is odd. So we have to increase the number by 1. So 18.4. Okay, I hope you understood the rules for rounding off the numbers. Let us see the arithmetical operations with the significant figures. Arithmetical operations with the significant figures. First one, addition and subtraction. When we are adding the numbers or when we are subtracting the numbers, the final result, how it comes? Actually, the final result depends on the number with the smallest number of decimal places. In the given quantities, which number has smallest number of decimal places, with that significant figure, we have to make the result. For example, 3.1 plus 1.780 plus 2.046. When we are adding these numbers, we will get the answer as 6.926. How can we round off this? So when we are adding the numbers, the final result may depend on the number with the smallest decimal places. This has only one decimal place. After the decimal point, only one. After decimal point, 3. After decimal point, 3. So here it has only one. So the last answer also you have to round off as 1. So 6.9 is the answer. Another one example, subtraction. 12.637 minus 2.42 equal to 10.217. When we are subtracting, answer is 10.217. How it will be rounded off? So this number has, after the decimal point, smallest number. So we can write the answer as 10.22. Why we are writing 22? Here the number is greater than 5 and the previous digit is odd. So we have to add 1. So 10.22. The next one, multiplication and division. When we are multiplying and dividing the numbers, the final result depends on original number with the smallest number of significant figures. So when we are multiplying and dividing, you have to consider the whole number and you have to make us a significant figure. Which number has smallest significant figure, with that number we have to round it off. But in addition and subtraction, after the decimal point you have to consider the smallest number. Here the whole number. Final result depends on original number with the smallest number of significant figures. For example, 1.21 into 36.72. When we are multiplying this number, you will get 44.4312. Here, how will you round it off? This has, the whole number has 3 significant figures. Here it is 4. So which has the smallest significant figure? This number. So this also should be rounded off to 3. So we can write 44.4. Let's see the division. 36.72 divided by 1.2. When you are dividing these two numbers, you will get the answer 30.6. So it should be rounded off to the original number with the smallest number of significant figure. So here it is 4, here it is 2. So here we have to make it as 2. So 30.6 can be written as 31. Okay, this is the arithmetical operations with the significant figure. Students, today's class we have discussed about the significant figures as well as rounding off. Then arithmetical operations with the significant figures. So I am giving the homework. Try to do this problem. Which of the following has the highest number of significant figures? A. 0.007 meter square. B. 2.64 into 10 power 24 kilogram. C. 0.000632 meter square. D. 6.3200 joule. Second question. If pi equal to 3.14, then the value of pi square is A 9.8596, B 9.860, C 9.86, D 9.9. Find the answer. Actually, this question is the multiple choice questions from your book. And also, you have to write the rules for determining significant figures and write short notes on rounding off. Thank you, students.